Well, I must admit, I was very surprised by the amount of response that we got with our story about Introduction to CNC Routers back in issue number 12. A number of you called in, sent emails and so forth, voicing your opinions and your thoughts on this particular machine. Now, as I mentioned back then, we're hoping to present this as a project story so that you can build your own CNC router. Now, I'll be the first to admit, this is not going to be a real cheap machine to build. It should cost in the range of about a good cabinet saw. But as with a handheld router, it's a very versatile tool, so you can actually get a tremendous amount of function and use out of the machine. Now, I have been wrestling with some design issues on it. I'm trying to balance performance with cost, and that's been part of the changes that we've made here in the past few months. I've also added some other little toys and bells and whistles along the way just to keep it fun and exciting. So we'll walk you through some of those changes right now, and then in our next issue we'll try to update you again on any further improvements. One of the things you probably noticed right away is that the keyboard is now in a different location. We took it out of that box that we had hanging on the back. We just built a simple bracket on the back that hangs on this bar up front. Just a very simple change in addition to it. Now, the next thing that we did, frankly, this is just more of a fun thing. It does add a lot of function to the machine and make it a little bit more ergonomic to use, but we'll just quickly talk about this and keep in mind that this particular portion of it is purely an option. You don't need to go through all this detail and wiring and so forth to get this type of function. Now, all of these buttons, switches, and levers and so forth actually exist in the control software. You can click the mouse on the screen to perform any of these functions. However, many operators like to have an operator panel that's ergonomic, has easy to touch buttons that are large, joysticks to move the axes around and so forth, and it just makes it a nice logical layout for you. Now on here we've got a number of controls. We've got our spindle on off, dust collection on off, vacuum clamping, our cycle start, feed, hold buttons, our reset button that stops the program and rewinds it. We can use these buttons here to change the way that these two joysticks operate. If we hold the joystick over in one mode, the table will continuously move. In another mode, it'll just move a few thousandths of an inch each time. We've added controls here that allow you to control the speed at which the axes move when we're jogging it manually. Up in here I've added a rewind button for the program, so if I stop in the middle I can just rewind the program. And then these are conditional switches down here. They change the way the CNC program actually runs and executes. We can run it one line at a time, we can have it stop at certain points, and we can even have it optionally skip certain lines. These blue buttons up here allow me to select the different modes of the machine, such as program editing, automatic cycle, manual data input, jogging, and then even plotting. Now, because Windows-based computers, you have to have a mouse, and mice don't work out real well out in the shop, trackball was a nice logical choice for me. It's very awkward to get used to, especially if you've been mousing for many years, but it seems to be performing very well out here. I also decided to add a numeric keypad because there's oftentimes an awful lot of numbers that you need to key into the control for changing offsets and so forth. And there's a few other controls on here that we'll be adding as time goes on. One thing that's a very important feature that we want to add down on this panel is an emergency stop button, and that would go in this location right here. But oddly enough, this whole series of buttons, switches, joysticks, and all this stuff has nothing to do with CNC. What we found was a device for using with making arcade games. And what it does is it allows you to attach all of these buttons and switches to that device. That interprets them as regular keyboard switches, translates them, and passes them on to the computer as if we were hitting a button on our computer's keyboard. So it was one of those crossovers of technology. A gaming tool worked out well for a CNC operator panel. Same thing with the joysticks. Now, I would like to point out that this can get very expensive with all these switches and so forth. And again, I'm mentioning It's strictly there because I wanted it there. I don't need any of this to operate the machine, well, with the exception of the trackball. You will also notice that we moved the computer back here and the monitor up on this platform. It's a little bit high, especially if you're a bifocal person where you got to look down at the bottom of your glasses. But we're just trying different places to locate things to see if we can make it more ergonomic. To get this equipment up here, we just simply took our control box, which had the driver board and power supply in it, mounted it on a board out here, and that got it out of the way. Now, I've also been experimenting with some electronic and mechanical components to improve its performance. Now, I will admit I'm trying to get this thing to perform like an industrial CNC machine, but on a very inexpensive budget. But we did change out to a different power supply and a different driver board to control the stepper motors. This allowed us to get much faster rates out of the machine. Now that's running at about 350 inches a minute. Very, very fast for a CNC machine, but slow by today's standards. Many of the large industrial machines are going at upwards of 2,000 inches a minute. Very, very fast. On a home-based CNC router, we don't need that type of speed performance. But what I have been focusing on is getting our cutting performance up there. I want to be able to cut at a very fast feed rate relative to where we started with the machine almost a couple of years ago. So we're working on that performance issue. Now, not only are we working on performance, but we're also working on trying to keep the costs of this machine within reason. However, I'm not going to sacrifice performance and reliability over price on the overall design. Now, one of the elements of the machine is called a ball screw. That's this device down here. It's like a regular screw, except for instead of the nut touching mechanically to the screw, there's ball bearings in between the two. They're very efficient in transferring rotary motion into linear motion. Now, this particular size and so forth is very economical compared to what we could end up with on here, which could easily make this screw component about 10 times more expensive. But I really don't think we need to go to that level because these screws are performing good. However, we did try to go the other way, back down to what's called an Acme screw, or an Acme lead screw. We've got a nut buried inside this little coupling. This coupling connects to the motor, and then we have an end bearing out on it. Now, these will give you very good precision, but the performance of them, the efficiency of converting this rotary motion into linear motion is not as good as a ball screw. So in our testing, it worked. I really didn't like it though. I'd rather go with the extra cost of the ball screw. I've also been experimenting with the weigh system, which guides each of the axes. I'm still using the UHMW bearing pads, and that's working out very reliably. However, I did go with what I call a master and a slave weigh system here on the x-axis. Now, if you remember before, the ball screw was centrally located between the two weighs, and we were getting our directional guidance off of both weighs in a different configuration. I've since gone to this master-slave weigh system and then moved the ball screw in tighter to this particular weigh, which is providing our linear guidance. That proved to be a very good change that we made along the way. It's improved performance and reliability. Clamping work down to the table for milling is one of those things that you can get extremely elaborate with or very, very simple. During about the first full year of testing, we did one of two things. Either we screwed the workpiece directly down on our work table, or we used double-face tape. Both worked very, very well. But there is a more elegant solution, and that's called a vacuum table. Now you can see a series of grooves in here, and then this O-ring cord stock that plugs up those gaps. Here you can see some holes that allow the vacuum pressure to build up underneath here, allowing atmospheric pressure to push the workpiece down. I've also got some wedges and other devices on here, but these are all still in the experimental stage. Now with this vacuum clamping, I did find something very interesting though. We started out with our vacuum pump as the device to draw the vacuum underneath here. But my vacuum pump doesn't have enough airflow to overcome all the leakage on such a large table. Now this is all glued together, plywood and so forth. There are no leaks at any of the plywood joints and so on, but just the porosity of the wood allows air to penetrate through it, and then the vacuum would not build up. So we ended up switching over to a small shop vac, and that's proving to work very well. Now, as I mentioned back in issue number 12, we had tried out some new control software. It's proven to be an outstanding piece of software. It's been very reliable, it's working very good, very fast, very efficient. So I'm all around very happy with that aspect. Now, there are a couple more mechanical items that we need to change on this machine that aren't performing very well. So we'll be experimenting with that over the next few months. Now, in the meantime, if you've got questions or comments, feel free to drop us an email, and we'll be glad to discuss some of the attributes of the CNC machine. You can also go onto our website, and on the right-hand side, we've got a discussion group link. There you can go in and participate in various discussions on our forum. And feel free to ask questions about the progress of our CNC router. I'm Chris DeHut for Woodworking at Home. Hope you enjoyed our update.